Hi there. This is the continuation session of our previous lecture on laws of motion. And if you haven't gone through that already, I would recommend you to do that once, okay? Before proceeding further, I just want to let you know about one thing that I noticed among lots of students that you feel some sort of insecurity when you start doing numerical problems. In order to resolve these issues, I have two very important tips for you, which I am going to share with you today. The first one, which you have heard a lot, that you need to focus on the theory part, which is indeed very true. And I am also emphasizing on this fact that try to go in depth of the concept, at least whatever you are learning. It is true that curriculum is quite vast and time is relatively less. So, pointing out some key topics which are easily scoreable is definitely a great idea. However, if you want to see yourself as a topper, then you need a grasp on your entire curriculum, okay? Now, once the theory part is clear to you, but still you are not able to crack questions, it means that there is a lack of applications of concepts, right? Therefore, the second most important thing when you are working on the exercise problems is think whatever you know to relate it with that question and how you can use it to get into nearer to the answer, okay? But you should not spend more than 15 to 20 minutes on a single question. Instead, at this point of time, what I would suggest you to work out on previous year question papers and go through the solution in case you are not able to figure it out by yourself. Well, this does not mean that you have to mug up the solution, but learn how the concept which you have learned has been applied in that question. And most importantly, try to realize where you went wrong in solving that question, okay? Okay, just remember these points and let's start our today's session. Given a figure shows the initial position I and the final position F of a particle, what are the initial position vector Ri and the final position vector Rf, both in unit vector notation? Okay, so let's start with the problem A. We have to determine Ri vector. So observe that this is the positive x-axis. This one is the negative z-axis. Because this side is positive, therefore this side would be negative, right? And here this one is the positive y-axis. Therefore, this one will be negative y-axis. Now we know that the unit vector along x-axis is denoted by I cap, right? And along y-axis, now whenever I say x-axis or y-axis, I mean positive x-axis, okay? So the unit vector along positive x-axis is I cap, along positive y-axis is j cap, and along positive z-axis is denoted by k cap, right? We denote this as origin. Then the coordinate of this point is 4, 0, 0, right? Because this is on the positive x-axis. The coordinate of this point is 4, 1, 0, right? Because this moves 1 unit or 1 meter along positive y-axis. And then we came here, right? Now, what is the coordinate of this point? The coordinate of this point is both x and y will remain same. Only the z part will get changed because
it shift from 2 unit from here, right? And this 2 unit is along negative z axis, right? Therefore, it would be -2. Now again, it shifted 3 unit along positive x axis because this side is the positive x axis. Yes. If we see, according to the graph, this is along x axis, this is along negative z axis, and this is along positive y axis. So since it shifted from here to 3 meter ahead along positive x axis, therefore the coordinate of this point is 4 plus 3 and rest 2 will remain same. So we obtain the coordinate of this point, which is basically Ri vector. In the language of vector components, we can write this as 7 I cap plus 1 j cap plus -2 k cap. Okay. Similarly, we can also solve the problem B. Now, can you try it once by yourself? Observe that in this case, let me draw a separate line here. So, this is positive z axis according to the question, and this is negative y axis because positive y axis is in this direction. Therefore, the downward would be negative y axis. So, let us now determine the coordinate of each of these points mentioned here. Okay, so this is one point, this is one point, this is one point. So what we are going to do, we will do step by step. We will first determine the coordinate of this point, then we will obtain the coordinate of this point, then the coordinate of this point, then finally coordinate of this point will be obtained. So can you try it by yourself? Can you tell that what would be the coordinate of this point? Because this one is 4 meter or 4 unit, and this is z axis, and on z axis the y and x part will be 0, therefore 0 0, and since we move along positive z axis, therefore it will be 0 0 4. Now what about the coordinate of this point? We have moved 3 unit along negative y axis, right? Therefore this is -3. Till now x part is 0 because we are on the yz plane. Now what about the coordinate of this point? Now observe that this distance is 4 meter, right? But in this case, what is happening? We are going backwards to the 4 meter, right? We are moving in the opposite directions of 4 meter. It is something like this. We came here 4 meter, then we again go opposite to this direction 3 meter. Therefore, our displacement is 4 minus 3, right? Equals 1. So the coordinate of this point is 0 minus 3 1. Yes. Now we have the coordinate of this point. Now we have shifted 5 unit along positive x-axis. The coordinate of this point is 0 plus 5 unit, 0 plus 5 meter, and rest 2 will remain same. So we obtain the final position vector 5 I cap minus 3 j cap plus 1 k cap. Okay. Now in the last problem, what is the x component of displacement delta r vector? Now we know delta r vector is defined by this expression: final position minus initial position of a particle, and we obtain our RF vector is 5 I cap minus 3 j cap plus 1 k cap minus our Ri vector is 7 I cap plus 1 j cap minus 2 k cap. Now if we subtract this, we obtain minus 2 I cap minus 4 j cap plus 3 k cap. And the question here is, what is the x component? So we have to determine the x component of this vector, right? So which one is the x component? This one is x component, right? Therefore, the x component of displacement vector, which we can write in this way, r suffix x, is minus 2. Given a positron undergoes a displacement delta r vector with this component along x, y and z axis, ending with position vector with this in meters, what was the positron's initial position vector? So the final position vector, because it is the ending position vector, therefore this is our RF. Yes, this is 3 j cap minus 4 k cap, or we can write this as 0 I cap plus 3 j cap plus minus 4 k cap. Okay, and changes in displacement is delta r vector given by 2 I cap plus minus 3 j cap plus 6 k cap. And we know that this we can write as in this way from the definition. Yes, as we have seen in our last problem. Now in the question they have asked that what is the positron's initial position vector, that is we have to determine this one, right? So it's very simple. We know RF, we know delta r, so we just have to do the arithmetic here. Delta r vector equals RF minus Ri. This implies Ri vector equals RF vector. Okay, so we will now just substitute the value minus delta r vector, which is this one, 2 I cap, and if we simplify this we obtain, therefore the initial position vector of the positron is given by this. Okay, Antonia stands at the edge of a vertical cliff and throws a stone vertically upwards. The stone leaves Antonia's hand with a speed v equals 8 meters per second, and the time between the stone leaving Antonia's hand and hitting the sea is 3 seconds. Air resistance is negligible. Let's draw the graph roughly. So let's say Antonia is standing at a vertical cliff. Let's say this is the vertical cliff, and she is standing here and she throws a stone which will definitely go to the upward, and then it will fall at the sea level. Okay, let's say this is A, this is P, and this is B. So the first problem we have to determine the maximum height reached by the stone. So you have to determine this one. Let's say this is h. So, as we have seen in our last problem, the maximum height reached can be determined by using this formula. And we know at the maximum height, this part is 0. Yes? And we will assume the A as gravitational acceleration. Since the ball is going upwards, therefore acceleration will act downwards, and for that reason the symbol is negative. And we need to determine the maximum height, that is S equal h. So this gives uy square equals 2gh, and we know our initial velocity is given 8 uy equals this 8 square 2 times 9.8 times h. Simplifying, we obtain which is almost approximately, we can say 3.26 meter. Okay. So this is 1. The time taken by the stone to reach its maximum height, how much time does it take? Which we'll obtain with this equation. Yes, Vy equals 0, Uy equals Gt, and from here we obtain T equals Uy by G. We know Uy equals 8 and G is 9.8. Simplifying, we obtain approximately 0.82 second. Okay. Okay, so now the final question, the height of the cliff. So this can also be done. Now see, if we assume this as h naught, then let's draw a horizontal line. Then this one will also be h naught. Yes, we have to determine this h naught. Now in this case, what we are doing, we are neglecting the height of Antonia. Okay. So if we neglect the height of Antonia, then the time it took to reach from this point to this point will be same to reach from this point to this point. Yes. And we know the time it took from reaching from here to here, it is almost 0.82 second. Therefore, from here to here, it will take 0.82 second by the symmetry. So, the time it will take from here to here is total time minus, let me just number this, it is B, minus 2 times 0.82, yes. And we know the total time is given as 3, therefore 3 minus 2 times 0.82, which if we simplify, we obtain, it is 1.36 second. Okay. Therefore, the time it took to reach the bottom level from here is 1.36 second. Now we know the time, and we also know the velocity at this point, which is given as 8 meter per second. So we know velocity, we know time, therefore we will apply this formula, ut plus half at square. We know our u is 8, our t is 1.36 plus half. Our acceleration, since the particle is falling downwards, right? And acceleration is also acting downwards. Therefore, in this case, our a will be plus g multiplied by 1.36 square. And if we now simplify this, we obtain the height of the cliff almost 20 meters. Okay. Given a train at a constant speed 60 km per hour moves east for 40 minutes, then in a direction 50 degrees east of due north for 20 minutes, and then west for 50 minutes. What are the magnitude and angle of its average velocity during this trip? So let's first draw the diagram. We have our speed is constant. Let's use some different color. So let's say the particle is moving east. This is our east. Then it's moved obliquely an angle 50 degrees east of due north. Therefore, this is 50 degrees, okay? And our this one is 40 degrees. After it starts to move along the direction of west for 50 minutes. Okay. So let's first write here this our E along this direction. It moves for 40 minutes. Yes. Along this direction it moves for 20 minutes. And along this direction it moves for 50 minutes. Yes. So what are the magnitude of the average velocity? So we have to compute the average velocity. That means we do not need the concept of calculus here, right? Because the average velocity can be computed using the formula as what we know, the general laws of motions formula. We can easily apply those formula. But if it is given to compute the instantaneous velocity, in that case, we need the concept of calculus, okay? Differentiation, derivative, okay? First, let's determine how much it moves along east. So let's say that total displacement is S, and let's say SE is the displacement along east, SNE is its displacement along northeast direction, and SW is its displacement along west direction. And let's say T is the total time, where TE is the time taken along east, TNE northeast, TW along west. So if we can determine these two, then from this we can easily compute the average velocity, the magnitude of the average velocity, okay? So first what we will do, we will start with this one, the total time. We have TE is 40 minutes, yes. This one is 20 minutes and this one is 50 minutes. We obtain 110 minutes. Yeah. Okay. So now we will focus on this one. So let's first compute the SE. First thing first. Now there is no physics here. It is plain arithmetic because the speed is constant and it moves 40 minutes along this direction. Therefore, it covers 40 by 60 times 60 equals 40 kilometer. Yeah. Similarly, we can also obtain SW. There is no physics here, right? It is simple arithmetic as what we have learned in our lower class. So similarly, this is also 50 by 60 times 60. That is 50 kilometer. Yes. All we have to do, we have to mention the vector here. Only here we need physics. Since east, we assume this as I cap, right? We assume east as positive x-axis and west as negative x-axis. Therefore, it will be let me take some different color. It will be minus of I cap and it will be I cap. Okay. So this we can write in this way. This is 40 I cap and this is minus 50 I cap. Okay. Now we have to determine this one, the displacement along SNE. Now it is also pretty simple. What we are going to do is, let's say this is O, this is X, this is Y. A particle is moving along this line, okay? And P is any arbitrary point. We assume the particle is moving with a constant speed. This is constant. Okay? Now, what would be the velocity of the particle at this point? P is any arbitrary point. So it is simple. The velocity of the particle at any point, let's say it is v theta, is given by this formula. I cap plus, yes. Therefore, the velocity of the train at any point, any arbitrary point, since the speed is constant, will also be attained with this formula. Yes. So we can easily compute here SNE. It is the speed cosine 40 I cap plus sine 40 j cap times t. Yes, this is the displacement by using the formula of S equals Vt. Yes. So now we know the speed. Now we are going to apply the same arithmetic here as what we have did in these two. So it is nothing but since it moves 20 minutes with 60 km/h, therefore it moves 20 by 60 times 60. This is the speed, and because of the direction, this thing will come. Sine 40 j cap. My handwriting is little bit dirty, sorry for that. But I hope you guys are understanding, right? If you have any doubts, please let me know in the comment section, okay? So we have to plug this into the calculator and we have to get the value here. So we finally obtain the total displacement, which is the sum of these three things, yes? So if we now sum up all together, we obtain 40 I cap. Therefore, the velocity of the train at any point is given by, that is the average velocity is S vector by t, and we obtain our S vector as 5.32 I cap plus 12.86 j cap by t, and our t is 110 minutes, right? And 110 minutes means 11 by 6 hours, okay? So it is something like this, 6 by 11, 5.32. By the way, this is the approximate value, okay? Because cosine 40 and sine 40 we have obtained here approximate. So you can write this as approximate. Better to write this as an approximate, okay? 12.86 j cap. This is the average velocity. Now in order to obtain the magnitude, what we have to do? We just have to take the square of the components. So it will be 13.91, which is 7.6. This is still an approximate value. I am writing 7.59, or you can also write this as 7.6. So the magnitude of the velocity or the speed is 7.59 km/h. Okay. So this is the part A of the problem. And we have another part here. Part B. What is the angle of its average velocity during this trip? So the angle obtained, the formula, with this formula we know tan theta is Vy by Vx component of the velocity along y-axis and component of the velocity along x-axis, which we have already here, 12.86 upon 5.32. Yes, because 6 by 11 will get cancelled out, so I didn't mention that term, which if we simplify, you obtain approximately it is 2.42. Okay, implies theta equals tangent inverse of this. In degree, the value, it is almost 67.5 degree.